we're going to start talking about wave properties, specifically frequency and period. So first, the properties of waves that we're going to talk about include frequency, period, amplitude, wavelength, and speed. Specifically in this one, frequency and period. So first, frequency. Frequency is denoted by lowercase f, kind of has a little bit of a squiggle to it. And frequency is how often the wave goes up and down or is compressed. In normal language, frequency is just how often something happens. And so here, it's how often the wave happens. We find that by taking the number of waves or the number of oscillations, which is just one occurrence of the wave, and divide it by time. This is going to be measured in hertz, where hertz is, again, named after someone, and so it's 1 hertz, 2 hertz, 3 hertz. And hertz is actually specifically 1 over seconds, so your time will always have to be in seconds. So our first example is how to find frequency. One wave crashes on shore every 5 seconds, so what is the frequency? So we're going to find frequency by taking the number of oscillations and dividing by time. And so we have one wave, so we have one oscillation, and we have a time of 5 seconds. And so we get a frequency of 0.2 hertz. Again, since time is in seconds, we can use hertz. Period is our next one. For period, we're denoted by a capital T because it's a type of time. Since it's a special time, then we do capital T instead of lowercase t. And period is the amount of time required for one oscillation or for one wave to go through. To find this, we divide total time by the number of oscillations. So you should notice this is a direct inverse of frequency. The units are any unit of time, seconds, minutes, hours, days, years, etc. And so normally we're going to also see seconds here. So here's the exact same example we just did, except now we're wondering what is the period. So period, capital T, is the time over the number of oscillations. So here we have 5 seconds for one wave, and so we have a period of 5 seconds. Now the relationship between frequency, and that should be period, not lambda, should be period. So the relationship between frequency and period is an inverse relationship, which means it's 1 over. And so you'll see that period is 1 over frequency, and frequency is 1 over period. So now let's use those in a couple of examples. If the frequency of a sound wave is 512 hertz, what is the period of that sound wave? And so we have period is what we're looking for, and we have the frequency, which means we'll use this inverse relationship. So 1 over the frequency, which is 512 hertz, gives us a period of 0.00195. And since hertz is 1 over seconds, then our unit here is seconds. For the second example, the period of a stadium wave is 7 minutes. What is the frequency in hertz? Since hertz deals with seconds, we have to convert minutes to seconds. To do that, just multiply by 60. 60 seconds in a minute. And we get 420 seconds. So now we just use our inverse relationship, 1 over period. And so we get 1 over 420 seconds, which gives us 0.00238. And that's going to be in hertz.